This is Complex Numbers, section 6.6, part 5. This is all about raising complex numbers and their trig form to powers, whole number powers. All right, this is actually a theorem named after the French mathematician de Moivre. And this is de Moivre's theorem that if you have a complex number z, and this is its trig form, r cosine theta plus I sine theta, and n is a positive integer, meaning a whole number, then z raised to the power of n is going to be equal to this. R raised to the power of n times the cosine of n theta plus I times the sine of n theta. So basically, you will raise the modulus to the nth power, and you'll multiply the argument by n. So once again, you're going to do something to the modulus and to the argument, but not the same operations. Okay, so if you're strictly doing this in trig form, it's going to be very easy. So let's say you're given this number in its trig form, and it's in degrees, so we'll just work it in degrees. Z equals 2 cosine 50 degrees plus I sine of 50 degrees. And the question is, find z raised to the 10th power. And we are going to just do it in the trig form again. Okay, so using de Moivre's theorem, we will take the modulus, which was 2, and actually raise it to the 10th power. And that will be 1024. And then you take the argument, 50 degrees, and you multiply that by 10. All right, see, this is raising to the 10th power. This is multiplying by 10. So you do have to keep track of that. That gives us 500 degrees. Remember, we want our arguments to not be larger than 360 degrees. So we would have to find a coterminal angle by subtracting 360, which brings us to 140 degrees. And that would be the answer right there. Z to the 10th power would be 1024 times the cosine of 140 degrees plus I times the sine of 140 degrees. It is much easier to raise numbers to powers in their trig form than in their standard form.